Okay, sorry. And then this thing never works when, there we go. We real quick did this bell work. You should be able to do this bell work. Sorry, everyone in class, just setting up those people here. Take a look at these answers, and then we talked about the rational zeros theorem. Just highlight these things, read it, stop the video, get your head in the right spot as far as what I have written there. And then here's the actual how it works. Now I'm going to approach this maybe a little different than last hour. I'm going to do what I do with my CAT students. Okay, so what I do with my CAT students is I right away say, okay, I'm going to make my plus minus P over Q list. I'm going to put it right here, and I'm going to do it lazily like I do with my CAT students. I don't want to write plus minus a million times. I'm going to put plus minus parentheses, and it's plus minus all of these things I'm going to write next. But this isn't the actual answer. This helps me get the answer. And then what you read there, hopefully you did that online. You did stop the video and go back and read. A lot of times we made students read back in the day, and they actually learned from that. But this is where P comes from. It comes from the factors of 12. So what are the factors of 12? Don't forget about 1 and 12. And then, of course, 2, and watch how I write this. 6, I pair them up so I make sure I don't forget any. 2 times 6 is 12, so 2 and 6 are factors. And then luckily I have enough space where 3 and 4 fit in here. 3 times 4 is 12, and I don't have any others. So the factors of 12 are 1, 2, 3, 4, 6, and 12. What are the factors of Q? Q comes from the leading coefficient, which is the top dog um, variable power. So 5 is the highest power. So the leading coefficient is simply 1. So this is all over 1. So I want you to understand what this actually does. Final answer, this one was easy. I will write it, and I will do this lazily where I don't have to write plus minus 1, 2, 3, 4, 5, 6 times. This is 12 numbers. Now understand what this does to a student living in the 90s without a graphing calculator. The only possible, not actual, because how many zeros are there actually for this? I'm pointing to the number. How many zeros are there? 5. There's 5 actual zeros for an x to the 5th. There's only 12 possibilities that could actually possibly be a zero for this, as opposed to infinity, an infinite amount of possibilities, because that's how many numbers exist in this world that we live in. And that's what it did for the student back in the 90s. And then you know what they had to do? Trial and error. They had to go ahead and start trying. Does 1 end up being a 0? Does -1? Does 2? Does -2? And so on and so on and so forth. And we showed them ways to shorten it up. There are other theorems that shortens the list depending on what you're given, so on and so on and so forth. You live in an age where technology, just in general, like I said about what the phone does for us, both good and bad, unfortunately, but it shortens it up even more where you don't have to worry about it too much. But we're still going to teach it to you because again, those without a graphing calculator, this is what you're going to have to do, and I'll show you what that is. All right, let's do it again. So P over Q. Now it gets a little different, and it's plus minus, and I will put it in parentheses. I'm going to put it in this fractional format again. P up on the top, Q on the bottom, and go from there. And this is a small one again. A couple other ones get a little bit more annoying. Factors of 2 are just 1 and 2. All right, and I should highlight that in yellow. And don't be a robot and just pick 4x squared 4 as the leading coefficient. No, this is not in descending order. That's one of the first things you'd have to do with this. If you were actually going to find the zeros, you should put this in descending order. And then 1 and 3. And then this is what I do to construct my list. Plus minus. I'm going to use parentheses again just so I don't have to write plus minus a whole bunch of times. And then I take care of my integral zeros first. So 1 over 1, 2 over 1, 1 and 2. And then I go to my fractions. 1 over 3, 2 over 3. So there's 8 possible zeros. Not a cajillion. That's a made-up number. All right. So for the students back in the day, they really appreciated this. Oh, okay. So I only have 8 possible trial and errors, but it's not really 8. As soon as I find one that works, then it would take care of business. And I'll show you what that means here when we actually find zeros from these lists. Okay, again, don't be a robot. Here's P, or where we get the P list from. I don't know why I'm writing it up here. It's just what I do with my CAT students because usually there's a whole bunch of stuff down here that we have to do. So factors of 8 are 1, 2, 4, 8. Who do we appreciate? And then what's the leading coefficient here? Again, a nice easy one. X to the 4th is the highest top dog thing here. Okay, actually a little different thing here. I like what happens on this one. So the factors of 2 are 1 and 2. All right, and I should get my highlighting here. P, Q, factors, factors. And in every combination, this is what I do with my CAT students, like I say again. Now let's put the list together from every combination of numerator over denominator. Let's do the over ones first, the integers. 1, 2, 4, and 8 for sure. And then let's go to the over twos. Okay, 1 over 2, that's unique. Right? What's 2 over 2, everybody? 1. Do I have to write it again? No, you shouldn't. What's 4 over 2? 2. What's 8 over 2? 4. You're done. So there's a 1, 2, 3, 4, 5, 10 possible zeros. There's not 10 zeros, though. There's only 4. The only possibilities could be from this list, though. So you really narrowed it down. It's a very powerful situation. What's the matter? You saying is that a 2? Okay. All right. And then this one's silly. You should actually know what the actual zeros are this like right now. Anyone want to raise their hand? The first person, raise your hand. What's the actual zeros? If I set this equal to 0, what would be the solutions? Oh my goodness. Yes. Nice. Actual zeros. Come on, where's my pen? Oh my goodness. There we go. It's starting to do a whole bunch of stuff. I did not ask for that menu to come up. It just pops up. Okay. The actual zeros, this is a difference of 2 squares. And I do want to do this. 3 halves and negative 3 halves. This is 2x minus 3 times 2x plus 3, a difference of 2 squares. And then you set them equal to 0. Am I right or am I wrong? Of course I'm right. Okay, but let's do our possibilities and show how this is kind of an annoying one. First of all, the factors of 9 are 1, 3, and 9. The factors of 4 are 1, 2, and 4. Right? There's only that. You only have a constant and a leading coefficient. There's only 2 terms. Taking care of the whole numbers, 1, 3, 9 over 1. And then 1 half, 3 halves, 9 halves. And then 1/4, 3/4, 9/4. Doesn't take too long to get all those combinations of numerator over denominator. But look at that list. That's a large list, and I really would not have done that on this question in reality. Okay, 9 halves, 3 halves. I just making sure I didn't make a mistake because I have a hand up. Go ahead. What's that hand? Can't hear you? I just got a bathroom call right in the middle of this video. Go ahead. Run out of the room. All right? Teachers always love that when they think, oh, this is going to be a great math question. Can I go potty? All right. Always love that. Okay, so let's look at this. Who knows the answer real quick? Raise your hand. Yes. Too late. Who's next? You're out. You got to be sure when you raise your hand. You're gone. He's so mean, that Mr. Samuelis. Which letter is the correct answer for not being a 0, not being a possibility? Nice. E. Don't say, oh, that's what I was going to say. You were taking too long. When you raise that hand, that should be the end of it. Here's P over Q. This is why you should be able to do this one pretty quick, though. Factors of 3 are 1 and 3. Leading coefficient is 2, 1 and 2. All right, so we could see, oh, and sorry, it's plus minus. So it's plus minus all these possibilities. So the cat way, where we put this numerator over denominator and look at all possibilities, I think it'd be real useful for this. I see 3 over 1, that means negative 3 over 1. Of course, 1 and negative 1 are always going to be a possibility because 1 is always a factor of a number. That's why those are out. And then I could see 1 over 2 right here. So 1 over 2 is definitely a 0. I'm looking for what's not, though. That's why I'm crossing these off. Okay, anyway, I think I'm going to skip in these examples, the P over Q list. All right, and then just move on to something different. All right, and show you how the graphing calculator can be your friend here. Okay, so imagine we don't have that picture. And I ask you the next part. Use the graph and synthetic division to write the cubic function in factored form. Then identify all the zeros. So I must write it in factored form and find the zeros. You could do it in reverse. That might be smart. Get the zeros and then turn them into factors. That might be a good idea as well. No rule on that. Okay, but let's make this happen. And I did spend some time with my second hour to do this. Whoops. Okay, so first things first, go ahead and get your calculator out for those that have it. And go ahead and type, and sorry on YouTube, but you can spend this time, maybe you should be doing this when you're at home, following along everything that we do in here. And if you don't, that's why we don't know what we're doing, all right? That's the bottom line. What can I do better? Actually follow along with what we're doing and actually do what the teacher asks. Get your calculator out and go ahead and type this in. And then don't worry about that. I'll show you what that did for us. So hit y equals, type in 5x cubed minus 7x squared, and then do follow along with me. Minus 49x plus 51. You can see your paper too. I gave you the notes so you can go from there. Gotta make sure I get my calendars next hour all up to snuff. It's always the last thing I think of, knowing people are at home. I don't have the calendar updated at this point. But by the time this video is done, and then be the first thing I put in the calendar, then the blank stuff. Okay, hit zoom standard. Then I want to show you why you get a different picture than what is supplied on your piece of paper of notes. I'll show you what something is identified as. What zoom standard does is make this go from 10 to negative 10 on the X and Y axis. And when you look at this picture, expectation of picture, you should understand that that loop goes really high and this loop goes really low, and it's cut off by 10 to negative 10. And then I want you to see, too many things pop up. Good, I'm glad that minimized. That doesn't look like this. It's because you should look at the bottom. You know what this bottom represents? Starts with a W, W-I, W-I-N. Come on, somebody say it, W-I-N-D. Window, thank you. All right, the window that you should pick in order to get this picture to look like that. So those are the X values. So hit window, just getting used to your graphing calculator, and change that to negative 5, not minus 5. That'll be a syntax error. Negative 5. I actually put my cursor over to the minus sign. And then negative 75 to 100 was their random. Whoops. Put that in the wrong spot. Negative 75. Darn it, I think I missed that. There we go. Negative 75. Oh, I got to hide this. That would be helpful. See, you can't say I'm going too fast. Taking forever. Boom. Now look at my graph compared to the graph over here. Identical, right? Looks just like it. Boom. Then I'm going to show you one more thing. You ready? I know this note thing already has this, but just look at that. Look at these zeros. I'm pointing at this one. What does that look like it is? What is that zero right there? I'll wait for someone to say it because I don't want to sit up here like a moron all by myself. Negative 3, one person. Great. What's that one, everybody? Whoa! What's that one, everybody? Uh-oh. Now, isn't that like a fraction, right? So that one's kind of problematic. That's not like the greatest. So I'm going to show you one more thing on the graphing calculator. I did do this with the other class because imagine you don't have this picture given. So imagine you type this in your calculator, you look at it, and then you can see these. But I want to prove and I want to show you something. Go to y equals, just bear with me, and try to remember this for next year. And maybe if I give you a question pertaining to this maybe on Friday, who knows? But put y2 equals 0. By the way, what kind of line is that? Don't say red, don't say straight. It's it's horizontal. Thank you. I love when people answer the question. Fine, I'll answer it just so he stops doing the. All right, it's horizontal. Actually, which axis is that? The x-axis or the y? X. So watch how my graphing calculator shows that. And now you better get used to this menu next year. One of the most popular menus is second trace, which is calculate. Now I know that this calculate feature has 0 there. I just don't like how the calculator does it. If you want to play with it later, they ask for a left bound, a right bound, a guess, and it's just kind of like a convoluted process. But it's a way of programming the calculator so that the calculator knows what it's looking for. What am I going to use? I put 2 graphs, and I would like to know where those 2 graphs intersect. It only works if you do y2 equals 0. Because I want to find out, I wanted to make sure that stopped, where these 2 graphs intersect, and all I have to do is go close to where they intersect. Oh, I know you know it's 1. And you don't even have to go right on it, but notice what it says. First curve, okay, fine. Second curve, notice I'm on the horizontal line. I don't understand why the calculator asks for this. Guess, I don't know what that means. I guess you're supposed to stay close, but what does it actually say at the end? What does that say? Intersection. Now I know they intersect at 1, 0, which means for the blue graph, it's at 1, 0 on the x-axis. Okay, now we can look at this other one real quick. Watch how fast it is. Second calculate. 5 intersect, but all you have to do now is just arrow over. I'm using the right arrow if you can see this. And then just hit enter, enter, guess, whatever, enter. 3.4, interesting, 0. So that is for, in case they didn't give you this picture. Okay, but fine. All that was useless. With this picture, I can pick any one of these. I choose to pick this one first. And I have to prove that this is a 0. So I'm going to use synthetic division to prove it. Now, here's the kicker. What goes in that box? Is it 1 or -1? He says 1. No one else said anything. -1. There we go. Good. Now there's a fight. All right. And then last hour, almost everyone I heard say -1. But remember, the 0 is 1. And then remember that they said we have to put this in factored form. So I'll call this f of x. And if 1 is a 0, I don't know why I put that parenthesis. If 1 is a 0, what is a factor? If 1 is a 0, what's the factor? X minus 1. So who was correct? What goes in this blank? Is it 1 or -1? It's 1. Someone still said -1. Remember, if the factor is x minus 1, 1 goes in the synthetic division blank. Okay? And that's okay. I tricked you on that. Those that made that mistake, hopefully you don't make it again. That's how we learn. That's the point. And it's a valuable question. Many people make that mistake. That's why I did what I did. And by the way, how would you know you made a mistake? You would not get what at the end when we do this? What would you not get at the end? 0, correct. Bring down to 5. 1 times 5 is 5, -2. Boom shakalaka. This is -51. And then this is 0. So there's proof. Wait do you see the second example, why this is necessary. Okay? Now you could do one of 2 things. You could deal with this depressed polynomial and factor it. By the way, good foilers, I'm going to use the other 0 to help me out on factoring this. What is that other 0? Right here, what is that other 0? -3. If -3 is a 0, then what is this factor? X plus 3. Good FOILers are what? X times what equals 5x squared? This is so easy. 5x. 3 times what equals -51? This is why good FOILers are good factors. What kind of 17, though? You people that did not figure out factoring and understand why I said good FOILers are good factors. All right? You got to jump on board, man, right away, and then it makes the rest of the year easier. This is why you've struggled. By the way, what would that make that 0? I know it was 3.4, but what is it in fraction form? Add 17 and divide by 5. I don't have the time for this. 17/5. Got it? Now, I could have done something else like synthetic division. I could have synthetically divided this depressed polynomial by -3. But when you get it down to an x squared, you want a factor. All right. So that's the power of these cubics. Wait till you get into this next year. You end up with like x to the 5th polynomials. And you got to synthetically divide 3 times to get it down to an x squared. And then either factor or use the quadratic formula. True that. Okay, let's not go to the graphing calculator anymore. Let's steal this picture. What's this 0 right here? Say it before I continue. Tell me. 5. So that means 5 goes into blank. And I'm going to use this space off to the right here. 1, -5. 2, -10. Prove it. 1, 5, 0. 5 times 0 is 0. 2, boom shakalaka. That's proof that it is a 0. You got 0 as a remainder. Now, on this one, you do want to deal with this depressed polynomial. Remember, this is an x cubed. Now it's an x squared. This was an x squared. This is the x constant. This was the x position. Now it's the constant. So this is x squared plus 2. And then this is the remainder. What's the square root of a negative? Say it on a Monday. What's the square root of a negative? No, not a positive. What's the square root of a negative? I number. Come on, get that folder. Pull that folder out. Square root of a negative. Then what do I have to put in front of this? Plus or minus. That is the correct thing. So zeros. We had 5. Here's the pen. So the computer's going to start doing crazy stuff. There we go. And then plus minus I square root of a negative, and then root 2, nothing happens. Now, this is the first time you're going to write this. Remember, we had to write this in factored form. And I'll call it f of x again. I don't know if it has a name up there. Does it? Oh, it does say f of x. So writing this in factored form. Sure, the 5 is fine. Writing this in factored form with an I number 0. Totally legal. For plus I root 2, it's x minus I root 2. For minus I root 2 as a 0, it's x plus I root 2 as a factor. And that satisfies this, set of directions. Find the zeros and put it in factored form. Or vice versa, factored form, then zeros. I think getting the zeros first, then factored form is a lot easier. Okay, then this is where this is building to. This is a question where we're on an even slope. No reason to even touch your graphing calculator. Use synthetic division to write the cubic in factored form. Then identify all the zeros. All right, well, it's kind of like backwards. We probably want to get the zeros and then write it in factored form. And I always like to show you a different way of doing something, and it really shouldn't confuse and boggle your mind. I'm going to show a little different way of showing synthetic division on this and show you the reason why. Because back in the day, we really had to do this. So we're going to write the coefficients. It is in descending order. Unfortunately, I think today, except for the bell work, we didn't have any missing terms. Be aware of any missing terms, otherwise you're going to jack up the whole question. But instead of writing it like this and have to do this 4 different times with putting 1 and then trying -1 and then trying 2 and then having to write 4 and then write it again and then write it again and trial and error, We could do this all in one shot if you could just do one thing for me. We're going to do 1, -1, 2, and -2 all in the same work. So don't write any of this. Don't write this. But I am going to emulate what I'm asking you to do. What I'm asking you to do is hold the simplest thing in your brain. And again, if you are numerate, if you are good with numbers, which is a big prerequisite for being in an honors math class, the pen's really jacking up right now. I just don't get it. Technology going backwards. This is all I'm asking you to hold your head. Good Lord. Okay, so what's the first step off to the right? What do I do with that 4? Bring it down. Guess what? You bring the 4 down here. What's the next thing you do? 1 times what? Hold. And then what do you do with that 4? What do you do with the 4 and a -16? This is all I'm asking you to do off to the left. 1 times 4 is 4. 4 plus -16 is what? You can do that. And if you say you cannot, then why are you in this high-level math honors curriculum? That has been the biggest problem, being numerate and being able to deal with numbers, adding and multiplying, negatives, positives. Huge, huge, huge. Go back to here. What's 1 times -12? -12 plus 19. Hold. What is that? Even if you have to use your calculator, you still would have to use it over there. Just use it real quick over here since you already know the process. By the way, is this going to be a 0? You could already see, yes or no? No. 1 times 7 is 7. 7 plus -1. Nope, not a 0. Move on. This is what they had to do in the 90s. This is how they did their trial and error. Just a series of multiply and adds until they found one that was actually a 0. I still think this has value off to the left. Not writing this ever again for this kind of question anyway. Now I move on to -1. Watch how this goes. So aren't all these 4s all the way down? Isn't that the first step, all the way down, right? Okay, but let's do the second one. What's -4 plus -16? No time, it's -20. We should have said that. What's -1 times -20? Holy cow, 20 plus 19 is what? Can't we just shut this one down and say this is not a 0? Right? All right, let's go to the next one because -1 times, that's -30, that's -45. It's not 0. I'm looking for zeros. All right, 2 times 4 is 8. 8 plus -16 is -8. Getting excited. 2 times -8 is -16. Plus 19 is 3. 2 times 3, boom shakalaka, is 6. 6 plus -6 is 0. All right, if you don't like this, then go ahead and do the 4 individual and keep writing it over and over again. It's fine. I just like to give those that can handle this and like it a chance to look at it a different way. That's the bottom line. I will tell you this, you're done with synthetic division. Because what do they ask you to do is write it in factored form and then find the zeros. So we already have f of x equals x minus 2 because we have a 0 of 2 that we just found. And then what you do with this remaining stuff is deal with the depressed polynomial. And I did do this the long way with the other hour. Then I want to get into a whole who goes where. It could be 4x and 1x or 2x and 2x. And my mind just got a little boggled. So my m is 12, 4 times 3. And I'll zoom in on this factoring. And my a is -8. Will not continue until someone tells me the magic numbers. What are the magic numbers that multiply to be 12 and add to be -8? -2 and -6. What do I do about that? I split up the middle term into those magic numbers. Sometimes this way is a little bit faster than trying to guess and check. I do argue that that's the case. That is, even though I'm a good foilers are, anyone? You still check at the end. Good foilers or good factors still come in at the end to make sure, wait a minute, was that right? Did I do that right? Kind of thing. You know what I'm going to do? I'm going to go to my final answer. Because now I know I pull out that 2x minus 3. And I'm left with 2x minus 1. Thanks, Pen. I'm almost done, and you just can't finish with me. Watch the screen do bloop, blop, blip, blop. There we go. Hey, good full letters are good factors. What's 2x times 2x? What's negative 3 times negative 1? And then middle term, negative 2x and negative 6x. Now, I will finish the video as you guys are walking out. We got some fractional ones here. And I did promise the other hour I was going to do that. Oh, I didn't want to erase that, though. Fumble! Oh, man, that was a bouncing fumble. Holy cow. Okay, so go ahead and put your stuff away. I'm going to go ahead and do this the only way, which is like this. 2, negative 3, negative 40, 60, 1. 2 plus negative 3 is negative 1. Oh, this doesn't even come close. Negative 1 plus negative 40 is negative 41. This is like 19. It doesn't even matter at this point. I wouldn't even want to see that number. If you know that's not a 0, just kill it and move on. 2. Bring down to 2. 2 times 2 is 4. 1. 2. Negative 38. So 2 plus negative 40. 2 times negative 38 is not negative 60. This is not a 0. This is what students did back in the day when they didn't have graphing calculators as an option. Don't freak out. Just bring down the 2. Half of 2 is 1. 1 plus negative 3 is negative 2. Oh, this one stinks. So half of 2 is 1. 1 plus negative 3 is negative 2. Half of negative 2 is negative 1. Plus negative 40 is negative 41. Don't bust your brain here. Just ask yourself, is half of negative 41 negative 60 plus 60? No, that is not a 0. So I'm taking the place of that long synthetic division way, doing the adding in my head. Don't freak out over this unless you're really bad with fractions, which does disappoint me. 3 halves times 2 is 3. 3 plus negative 3 is 0. Remember, add and then go down. 3 halves of 0 is 0, negative 40. Now, interesting, is 3 halves of negative 40 negative 60 plus 60, which would be 0. Half of negative 40 is negative 20. Negative 20 times 3 is negative 60. Plus 60 is 0. Boom shakalaka. So notice what we have here, though. Now I'm going to take this 2x squared minus 40 and set it equal to 0. Add 40. Divide by 2. Maybe a little too fast on that. So let's slow that down here. 2x squared equals 40. X squared equals 20. Square roots. And I'll slide this over to the right. Oh boy, running out of room here. No time, Mr. Samuelus. Yeehaw, gotta be a cowboy. So, square root of 20 is 4 times 5. Square root of 4 is 2. So x equals, no I number, 2 root 5. Okay, now be careful on zeros and factored form. Okay, so these are the zeros. Let's just get that over with. Zeros. 3 halves plus or minus 2 root 5. Okay, done there. Factored form. Notice the leading coefficient of this situation is 2x cubed. So I need that to be reflected in my answer in factored form. I'm going to take care of it right away with this 3 halves. That comes from, and could come from, not x minus 3 halves, but 2x minus 3. Think about it. Add 3, divide by 2. Okay, so this would be a viable factor for that. Then for these, I could put x minus 2 root 5, x plus 2 root 5, and then be assured that when I multiply these all out, I wouldn't end up with that 2x cubed as a leading coefficient. If you wrote x minus 3 halves here, times this, times that, it would not match the question that you began with. So do be aware that you do have to think about that at the end there. Okay. Gotta shut this sucker down.